So today we are going to be making some of these acrylic stand figures of the mascot for the Real Op project at UC Davis. So this mascot was created by Sparky38 on Twitter, and these right here are just two-part acrylics. We have a stand base and the actual standee. This is a test piece. Obviously, the cuts aren't perfect, and this was too small, but this is just a little proof of concept. So when it's done, it'll look pretty nice. So what we're gonna do is we're gonna cut out stickers. We're gonna print and cut stickers for this top part, that bottom part, whole sheet of them. And then we are also going to cut out acrylic for the base and this upper part to the custom profile of the character. So once that's done, the customer will be applying the stickers themselves just to save a little bit on cost there, because that's an assembly that they can do easily. So we'll give them some transfer tape and extra stickers just in case they need them. Normally I'd use this printer, which is a 44-inch wide roll printer, but I'm still doing some color calibration stuff on it, so we are going to use a normal printer for now. Vinyl Master Cut 5.0. Seriously, do not recommend anyone use it. It has this problem where if you go to create a cut contour on a vector, it works fine. It's supposed to, when I go here and do this, it's supposed to come up with a pop-up that says images detected, and then you can set up your contour cut. Now, I can get that to work if I use this outline tool. See, it's supposed to do that. However, this has lots of problems. So if you look at the hand over here, and I check this, look at that. It doesn't follow it at all. And you cannot change any of this to sharp. Like, there's no way to do it. It just does not work. And I contacted their support, and they said, oh, well, it works fine for everybody else. So try it on a different computer. I tried it on a different computer, still does not work. Alright, so yeah, after spending a large amount of time that I don't even want to get into manually arranging this, this is the cut and the print. It's pretty close. It's not perfect, but you got to remember these things are 3 inches tall, and there's error in the cutter itself, so this is as good as it's going to get without automatic registration mark systems and software that works nicely. So let's go ahead and print it. Oh, I like this stuff here, the Ava vinyl sticker paper. You can kind of use whatever you want. This stuff's pretty good because it's good outside for water resistance and whatnot. You do have to UV coat it though, because the ink in most printers is not UV protective. And I found that if you UV coat it, even just one coat, 2 is better, but 1 coat seems to work really good. So let's load this up. All right, paper's in. Let's do a print. Let's make sure that the DPI is turned up. I will say though, in terms of like software and the actual performance of this printer and its ink efficiency and colors, I'm very impressed. It's definitely more saturated than it needs to be if you don't set up a correction profile, but honestly, EcoTank, not bad. When you absolutely crank the quality, it sure does take its time, but you know, it's worth it because it actually produces a quality image. Start up the cutter. Alright, we got it clamped down in the machine. So I always like to run it through the rollers a little bit and make sure that this is lined up properly so that it does not go over any graphics, because they do leave marks even if you get them like completely clean. So you just have to be a little mindful of that. Alright, now let's go cut in our software. And then we already set the origin there. And there you go, it goes to the bottom mark. So I'm going to go ahead and set this to ultra fine, use the keyboard, and we'll use the numpad. So I got this little keyboard over here so I can control this from over here. And then I'm also going to put in this pen tool because this works a little bit better for finding the center, because this knife, it's very, very, very small. And it's extremely hard to tell when it's centered, and also it spins in there, so it could kind of be at any angle. So I'm gonna swap that out. It's real easy. Just open this up, pull this out, drop the pen in, lock it down so it's centered. And now I can turn this keyboard on and we can drive this with this. And now I just gotta line all these up in the centers. So we just went around and we checked 7 out of 8 marks, and this one looks pretty good. It's kind of hard to tell from this angle how straight it is. Maybe it's a little bit off, but we add a little bit of overcut so that it goes into this black outline, just a tiny bit, so that if there's any kind of error in that process, it should hopefully not show up. Now, I forget this like all the time. Gotta remove the pen and put the blade back in, because if you do it with the pen, it'll just trace everything and then you gotta print it again. So yeah, had that happen more than a few times. All right, now we're all lined up. Let's proceed with cutting. So now I'm in Lightburn. This is a laser cutting program, so I'm just making an array here of 6 of them. There's only 5, but I do want to keep one, test it, make sure everything works all right. So here we go, we got 6 of them. Now I just need to load the material in the machine. And in the meantime, our cutting is complete. So let's see, the edges look pretty good. You can see there's a little bit of tearing on there, so it might be time to switch this blade out. But we'll pull a sticker and apply it to one of those 6 test pieces and make sure that it looks okay. And if it doesn't, I'll replace the blade and we'll go ahead and do these again. Get this thing started up. So I already cut this. This is just, I buy 4x8 sheets of acrylic, which you can see here. And then I cut off sections that I need. So this is just a 2x2 foot piece of 1/8 inch thick acrylic. So just gonna load this in here. So we got the machine running. We got our material loaded in here. We don't have to worry about how straight it is, but you know, we'll do our best effort because we're barely gonna use any of this. So just, you know, this much, and then a 2 foot by 2 foot square is about that big, so I'm not going to use that much of it. So first thing we'll do is we'll set our height with this. Line that up with the collar, drop it down a tiny bit. There we go. This piece is large enough that it's not going to get pushed around by the air or anything, so we're just going to run a quick frame on this to see what the approximate output size is. So that's the output size right there. So that looks good to me. So I'm just gonna hook up the ventilation for this and then we'll get going. So let me engage my vent fan here. And then we'll go ahead and run this cut. So we let the smoke clear for a minute. So you pull it up in here. Ventilation's super strong, so it should be all good. I'm gonna try and hold this in place a little bit with my other hand and then slide these out so that we don't misalign everything for the second cut. Alright, there's that. Let's grab the stand base. There we go, there's our 2 parts. Pull these out and we'll check the fitment on them. Make sure they fit together nicely. So this is pretty perfect. With the paper on, it doesn't really fit in, and you gotta really kind of force it without the paper on. Oh, that was a little too rough on it. So actually, we're gonna have to revise that design a little bit. We'll make this like 0.1 millimeter wider probably. So I went ahead and changed this slot from 2.7 to 2.74 millimeters tall. So let's run another cut. One thing that always needs to be kept in mind is the balance between your tolerances fitting nicely and your supplier. So this is a different sheet of acrylic than I normally get. So it's a little bit thicker than the other one. So that's why I had to adjust that. So we'll go ahead and stick this in here now, see if it fits. And kind of seems like it's got the same problem. So it might need to go from 0.4 all the way up to 0.8 or even 0.1 and see how it fits. But we don't want it to wobble back and forth. Like you can see in this prototype here, it wobbles. So in another one that I made, it does not wobble. So we want to hit that balance of it staying nice and sturdy and also being easy and reliable to put together. The other thing I'm going to do here is I'm going to actually verify the thickness of this with a set of calipers. So this is 3.06 millimeters. So the reason that it was so under at 2.7 originally is because the laser beam has an actual width of cut. So it doesn't cut on the outside of your dimension, it actually goes down the center. So we have to find that balance. So 3.06 millimeter on this, I'd say let's try like 2.9 and we'll see how it goes. You can actually see here, I've already done this work. So I've already done several different sizes here to try and figure out which one works the best. And apparently I forgot what I chose there. So it's one of these. I'm guessing it's probably the 2.85, but we'll see. I honestly think I ended up settling on that 2.7 though, because if you look at the times here, you could see 9:43 p.m. I probably tried that, and then I was like, all right, this one works. Let's do a 2.5, see if we get the fitment any tighter. And I didn't end up using that, so yeah, I think that's what happened. So that's why the file was already at 2.7, but because my material changed to a different sheet with different thicknesses across the board, I need to just make up for that tolerance a little more. So let's try that 2.85. Alright, so let's see, 2.85. Oh, perfect. There we go. See, that's nice and sturdy now. I was going to go straight to 2.9. I was kind of second guessing myself, but 2.85 ended up being perfect. Alright, so let's get some peel action going here, and we'll test some of these stickers and see how they fit. The actual thing that needs to get done here first, though, is weeding. I got to remove all these little cuts that are on the inside, like these little tiny things in the middle of, like, between all the different gaps and whatnot. I got to pull all those white pieces out. So, just do that. So the peeling it out and just laying it on the table and putting it down method worked pretty well. Not perfectly, you can see it's off to one side a little bit, and that's just because static electricity, it just pulled right up onto it. This is the part that's pretty labor intensive, and I'm already doing a really good price on these, so just, you know, they should be able to do it. Just, you know, be careful about it and take your time applying them. So this is roughly what it's supposed to look like when it's done. So I'd say this is a pretty good prototype. So we will continue as planned. I might enlarge this a little bit because I had a little bit of a kerf. So basically the laser, as it cuts, it kind of like, it leaves a mound. So it burns hotter up front and it evaporates the acrylic. So it has this little taper to it, which is nice. However, it causes a little bit of an issue with this sticker coming off over here. So we'll just size that up by, I don't know, a millimeter or two, and it should account for that. All right, let's run this thing. There we go. Got all these. And I just did a quick fit check, and they all fit great. Here's some photos from Tim of the final product next to the actual circuit board that is going in the satellite. So that wraps it up for this video. Thanks for watching.